Hi guys, this is Iman Neo. Welcome to my channel. In this video, we are going to get familiar with camera and word component in the Flame game engine. So if you haven't seen the previous episode, I highly suggest you to check it out because we are continuing the work that we did in the previous video. So let's get started. At first, let's do a cleanup in our code base. So I will create a new file to store our player source code. We call it player.dart, and I will copy paste this code. We need to import flame components and canvas, and also colors from material. Oh, what it says. Okay, so in material we have canvas. And here we have our game. We can create a new file for this. We can call it my game. I wanted to rename it, but my game makes sense. Why don't we have access to the Flame game? Maybe we can copy paste this import. Okay. And here I will remove this unused imports. Import my game and also game widget. So this is the simplified version of our code base. Oh, it is too far. Okay. So we have player, which contains our player logic and source code, and we have my game, which is the game class. And as you remember, it is the root component of our game. Let's commit this code. Okay, git commit dash m. Separate files to keep different assets. Okay, now let me change the starting velocity to something like 0 because we are continuously adding gravity to the velocity, and it moves towards bottom, and yeah, it works. And also we can do this like vector 2.0. It is simpler form of having 0 and 0 in x and y. Now let's talk about the camera and word concepts in the game engine. I decided to use a visualized game engine to show you how camera and word components work. For example, I decided to use a Godot game engine. It's a 2D and 3D game engine. It is free and open source, so we can download and use it directly. So this is an empty Godot project. Generally, you have a word which is an unlimited space in your game. For example, you can put icons here as a component or position component in our Flame game. And this is your camera. For example, let me rotate the components a little to look different from each other. Okay, so we have a word which is big. You can see that this is an unlimited area. You can put your all your components here. And we have a camera, which is another component. As you see, camera is a node here. In Godot, they call it node, but in Flame, we call all the components, we call component. So you can move the camera. It is a position component, and when you move, you see that the part that the camera is showing is the part that will be rendered in the final result. For example, if you move camera here, it shows this, as you see here. And for example, you can zoom your camera, zoom in or zoom out. For example, we can say 0.5. It shows a bigger space of the word because it zoomed out. And for example, we can do 0.3 to show all the content that we have. And yeah, it is the camera component and the word. So simply, word is an unlimited space where you can put a lot of components in there, and camera is the section that your app or your game is going to render. For example, this camera can follow this player. For example, we can put camera inside this one, and when you move this component, camera moves. As you see, camera is focused on showing this component. And also we can put camera on other components. For example, now if you move this one, you see that camera shows a different position of the world. And also you can have multiple cameras. For example, as you remember, in Flame engine we had examples, and the default one is a 2-player, for example, game, and you see 2 different sections in one screen. The left one shows the green car and the right one shows the blue car. So here, for example, we have 2 different cameras, and each of them is attached to each car. So here, for example, we wanted to split the screen size equally to allow 2-player play at the same time. To have a better understanding of camera and word component, I have a game for you which you can take a look. It is called TTG Through the Galaxies, which is built by myself. So for example, if you open the Google Play link, yeah, as you see, we have some planets which are added to our world, and also we have a rocket. When you tap on the screen, it fires toward the planets, and when you hit a planet, camera moves towards the new planet. For example, if I can show you, yeah, as you see, when it hits a planet, camera moves toward that planet, and again you can hit to the screen to fire your rocket, and after that camera moves to another target. And also at the end, when you lose, you see a zoom out. Let me show you. Yeah, and I just did a zoom out to the camera. For example, by default it shows by zoom 1, and when you decrease it, for example, half or 0.2, shows it from top area, and you can see a lot of components because the camera is showing from top. So I just animated the zoom level of camera to have this beautiful effect, zooming out and fading the game. Okay, so now we have a basic knowledge of word and camera component. And in the Flame game engine, when you extend a Flame game, you have a default word and camera component. So we don't need to create them by our own. We can reuse them, and let's see how it works. For example, here we have, let me do this. And here we have camera, which we can pass our customized camera. We are going to use a customized camera. Let me open the documentation. Camera component. Yes, we need this kind of camera with fixed resolution. I will let you know what is it. Okay, so this is a camera which has a fixed resolution. For example, in this example, we say we want to have a camera which shows the content in a resolution which is 800 to 600. So in this way, there will be a camera which shows the content in a virtual size of 800 to 600. So if you scale up the window, it scales everything but keeps the consistency and keeps the aspect ratio. So if you are playing on a mobile, it decreases the size to fit the one side of the screen and shows a black area on the side that it does not fit, because it tries to keep the aspect ratio in all devices. Okay, let me change it to something like 600 on 1000, and because we want to have a rectangle, a vertical rectangle in our game. And here, instead of adding our player to the game, we are going to add our player to the word. So we have a word component here because camera is attached to a word. A camera shows a word. And for example, our Flame game has a camera and has a word. And as you see, our camera has a word property which is set to the word that we are using in the game. So in this way, let me run the app again. Okay, as you see, the player is on the right side of the screen. So let's see what we can do to put it in the middle of the screen. Let's see what happened. Okay, we are adding the player to the board, and player has a position like this. So if we change the position to 0, yeah, so as you see, when we have a camera and we have a board, 0 and 0 is in the middle of the screen, I guess. Let me remove this line of code to see what happened. Okay, this is 0 and 100. And what about 0 and 0? Yes, this is where your player stands in the middle of the screen. Okay, so as a test, let us create a component here. For example, we can say word.add. We can add a rect component, and we can say position, doesn't matter, 100 and 100, but in size we say 9999 and 9999. And let us put it behind the player. We need to have a negative position to move it top and left. As you see, this is we have a very large a square or a rectangle in our game. So the camera only shows a part of a screen with this aspect ratio, for example 600 on 1000. And if you resize the game, you see that it keeps the aspect ratio in every size. And if you have a small device, so the game scales down and it keeps the aspect ratio. Or for example, we can try an aspect ratio for 600 and 600. This way we will have a square game. For example, if your screen is this size, you see the camera is showing a square which is 600 and 600 in aspect ratio in the middle of a screen. And if you have a small device, you see that the whole game is scaled down to fit at the center of the screen. And okay, let us remove this rectangle component because we got the camera concept. And also I'm going to uncomment these 2 lines of code. Okay, so our player is working correctly. When you hit the screen, it jumps up, and this is the exact mechanic that we want. So we have a minor issue in our player. Let me fix that, and after that we can continue. At first, we can replace it with vector2.0, which is the same as vector2 constructor with 0 and 0 parameters. So this is the same. Okay, at first, let me introduce you the debug mode. When you, for example, in our game.onMount, we can say debug mode equals true. And when you run the app again, as you see, we have a text which showing the player position, and actually it should move with the player, but here we have an issue. That's why it does not move exactly with the player. And also it is supposed to show the bugs that our player has in the game. To fix that, I need to change the change the position to offset, because as I realized, draw circle or any method that you want to call on canvas needs a position from 0 and 0. So you're not gonna set a position of your player here. You are gonna work with 0 and 0, and then Flame draws your position on the correct position. So to do that, let me put vector2.0 here, and if you run the app again, okay, it needs offset. And if you run the app again, you see that it works correctly now. It moves with the player. And yes, the point is that this method, the draw methods on canvas work in a relative way. So you are not going to pass a absolute value. You know, our position is an abstract value which is from 0 and 0 of the game. And here you should pass a relative value. So for example, we can say, okay, we want to have 0 and 0. The other thing is that we need to define the width and height of our player. So as you see here, we only defining the position, but we need to add the size. For example, if we say vector2 400 on 400, or let me try 100, and if you run the app again, you see that this square is this square defines the width and height of your player in the Flame game engine system. So we need to fix this. Let me add a variable here, maybe a constructor variable, final player size, for example, or player radius, and it is 15. Yes, so it can be in the constructor, which is this dot player radius. You can make it optional, and what is this issue? Oh, so we need to remove it. Okay, final double player radius, and now we have access to this value, and here we can say vector2.all, which means both x and y value, it should be player radius times 2, because radius is half of a circle. So here we need to multiply it with 2. So we have our size, and here we can use this variable instead of hard-coded 15. Okay, so now we have our circle, which is drawing in an incorrect area. We need to draw it inside the box or the circle, the rectangle. So to do that, we need to add an offset, which is half of the you know, here needs the center of your area that you want to draw a circle. For example, here we can say size divided by 2 and 2 offset. Okay, so it is working correctly, and the only thing that I want to show you is anchor offset. So here we have an anchor offset which says from which point of this component Flame should grab your component. For example, if you say anchor dot top left, which I think it is the default value, Flame grabs your component from top left. When you want to rotate it, it rotates from top left. When you want to move it, it moves from that point. So here we need to set it as a center. Okay, so now we are pretty sure that our component is in middle of a screen at the start and in horizontally, and also it has a correct size, and anchor is centered. So now we can remove the debug mode, and the next step is to add a logic to our camera to follow the player, you know, to move with the player. And before that, let me add some test components. Board.add, for example, rectangle component. We can say position should be vector2 x minus 100 and y 100, y minus 100. Size should be vector2 dot i20, for example, and let me run the app. Okay, so as you see, we have a square which does not move through the game. So with this static component, we can see how our camera works. For example, if we move the camera up, we can understand. Let me add some more of this component. We can say 100 minus 100 minus 200, and this time 100, and again minus 300 and 0, minus 400 and 100. Oh, sorry, like this. Okay. Now we have some components to which does not move through the game. Only our player moves, and in this way we can realize how camera works. And now we can do some logic here. We have access to camera here, and camera has a method called follow, which you can pass a position provider component, which our player provides a position. And if you run, as you see, camera follows the player. And simply, camera has a position, X and Y value, and our player has a position too. So in this case, what a camera does is following the player with the exactly X and Y value that the player has. So we don't want this logic. We want our camera moves only top. And if our player falls down, we don't want the camera moves down. As you play the color switch game, it works like this. So we want to define a logic by ourselves to not follow the player all time, but when player moves top. So let me remove this logic. Camera is not moving, and now we can maybe we can do the logic here. So we can implement update method of our game, and we can say camera dot viewfinder. So viewfinder has a position. We can set it equals to mPlayer.position to see that how it works. This is the exact logic that camera follow has. Okay, we can say that this is the camera position dot y, and this is the player y. And I will comment this code. I can say if we want to check if player.y is something lower than camera.y, it means that player moves top and our camera should follow. So we can say if player y less than camera y. Now we can say, what's the position? Oh, this is the issue. We can say camera viewfinder position.y equals to player.y. So let me run the app. Okay, it doesn't work. What if we remove this if statement? It doesn't work. It's weird. Oh, I think I know what's the issue. So what if we do this? Yes, so you cannot set y and x values of a position. It seems you can only pass a vector to as a position here. So we can say 0 and player y. And if I run the game again, yeah, as you see, when the player moves up, camera follows, and the player moves down, the camera does not follow it because of this statement. I mean, when the player moves upper than the middle of a screen, which is position of camera. With this logic, we move the camera upward, and otherwise we don't. Yes, so now we have a basic mechanic of our game, a color switch game, and let me finalize this code. We can remove these test components. Yeah, as you see, it is moving, but we cannot see other things. That's why you don't understand that it moves. So we have this resolution, background color, camera, and here in our player we have fixed everything, and yeah, that's it. Let me commit these changes. Git status, git commit sham, add camera follow player logic. Okay, now we have our camera logic. When the player moves upward, our camera follows the player. And in the next episode, we are going to work with sprite components and also drawing a custom shape to show a circle with different colors in different parts, and also rotate it because we want to make it challenging for our player to go through the color that matches with the player color. So stay tuned for the next episode. Don't forget to like and subscribe the channel if you like this video and this series. See you. Bye bye.